Okay, so this is about as complex radical equation you can find at this grade level. Basically, if you want to solve this, you're going to have to look at foiling that. It's not the most efficient method. If you move one of the square roots to the other side, change the sign, of course. Okay, when you go to FOIL this thing, like to square it, it'll be a little bit more efficient than the first. So if you square both sides to unlock these arguments, or these radicands, so you have x plus 2 is equal to the square of 3 minus x under a radical. Just important to note that when you square the right hand side, it's a binomial. You do it correctly. So we're going to square this. If you don't quite understand perfect squares that well, it's important just to, like, it's easy to just draw the square like that. The square has length and width that are the exact same. And when you go to FOIL this, 3 by 3 is 9. That's the first term. The last term, the two radicals will cancel, the two negatives will cancel, and you're left with just 3 minus x. Now the two middle terms in the expansion will be negative 3 times 3 minus x. And because it's a perfect square, this will also be negative 3 times 3 minus x. And of course, these two middle terms here are combined. So the answer to this expansion here is as follows. Okay, first term 9, last term 3 minus x, and the middle term gets doubled up, so we have minus 6. Okay, now we wish to isolate this new radical that we've created in this equation. So in this step above, we had two radicals. After that, now we only have one radical. So we are making some progress. So I'll move this thing over to the other side. So on the right you have 9 plus 3 and minus 2. And we have 1x moving across, and we have a minus x here. That's minus 2x. Simplify for this. Okay, I erased some preliminary work so I have room. So now, in order to solve this, I have to, again, square both sides. So when I do that, there's a little 6 here that you can move it to the other side and divide by 6. Do this and divide that by 6. But then you're going to have fractions, and then you're going to have to square it, so it's going to get quite ugly. So I would recommend not canceling that coefficient of 6 and just squaring both sides. Now when you square the left hand side, you make sure that you square all the products, a and b, so it'll be 36 times 3 minus x on the left hand side, 6 squared, and square root squared cancel, leaving the argument. On the right hand side, again, you'll have a perfect square. I'll illustrate that again. Perfect square, so the length and the width are the same. So when you go to FOIL it, or expand it, 10 by 10 is 100. And the last term, negative 2x by negative 2x, positive 4x squared. And the two middle terms are be a negative 20x each. So when you combine those, you'll get negative 40. So the right hand side here is equal to, okay, expanding the left hand side, you have 36 by 3, that's 108, minus 36x, and that's equal to 100 minus 40x plus 4x squared. Isolate everything on the right hand side there, keeping this guy positive. So 100 minus 108 is minus 8. Minus 40 plus 36 is minus 4x. And you have a positive 4x squared. Just clean this up. Factor out a 4 on the right. And you have minus 2 minus x plus x squared. Which will factor into x minus 2x plus 1, leaving you two solutions, namely x equals 2, x equals minus 1. At this point, you're going to want to verify these solutions. Occasionally, you can get extraneous solutions. So we go to check x equals 2. Plug it into your original equation there. X equals 2, you have root 4 plus root 1, which is 2 plus 1, which is 3. So this guy's good. Plugging in negative 1, you get root 1 plus root 4, which is again 1 plus 2, which is 3. So this one's good as well. And you're done.